In this video, we're going to look at section 2.7. So this is on page 178. All right, find the following sums. List the items being counted in each problem. In other words, what would the label be? All right, so I'm just going to give you a second, see if you can do these first three. I think they're pretty straightforward. Alright, so the first one, obviously, if we have 2 cats plus 3 cats, we have 5. And what do we have 5 of? We have 5 cats. So we're really focusing on, you might think this is a little silly right now, but there is a meaning and a purpose to this. 5 is our quantity, 2 plus 3 is 5, and cats are what we're counting, and that's going to be important here. Now this one might be a little bit harder to think about what the label is, but you have 2, if you say it out loud, you have 2/5 plus 1/5. 2/5 plus 1/5. So we have 3, what do we have 3 of? We have 3/5. Fifths are what's being counted. You could, if you think of this as, you know, the old pizza cut up into 5 slices. So these are fifths. Each of these is a fifth. Pretend like those are equal. Alright, so if we have 2/5 right here, plus 1/5 right here, we have 3 slices, and how big are those slices? They're worth a fifth of the pizza or a fifth of whatever you're doing. That's why we have to have a common denominator, right? We can't say 2/5 plus 1/4. That's like saying 2 cats plus 1 dog. We have to get a common denominator when we're adding, so because we need to add the same size slice. Alright, so similarly here we have 5/7. Alright, let's look at number 2. Now we're going to add things together. We've got 7 cats, 2 dogs, 3 cats, and 4 dogs. Alright, so what do we have? Well, we can add the cats together, right? We've got 7 cats and 3 cats, so we could say we have 10 cats. And we've got 2 dogs and 4 dogs, so we've got 6 dogs. Now we can't, well, we could combine these together and say 16 animals or something. We'd have to change the label, right? But as far as adding up what we've got, we would leave it at this. We wouldn't simplify it any further. Here we've got 5 quarters, 10 dimes, and 20 quarters. So we want to add our quarters together. We've got 25 quarters and 10 dimes. So I'm going to abbreviate a little bit here, like that. And actually, I want to go up here and I want to abbreviate this. Let's say I rewrote cats as just C. 7 cats and 2 dogs and 3 cats and 4 dogs. That might be a way to abbreviate that. So I could add my 7 cats and my 3 cats to get 10 cats, and my 2 dogs and my 4 dogs to get 6 dogs. Alright? Number 3, find each sum using the given units, then convert to a common unit and combine further. Okay, so as we talked about, I can add the 2/3 and the 5/3 because they're the same size, but right now I cannot add the 1/2. That's a different size. So 2/3 plus 5/3 would give me 7/3, and then I could still add a half. All right, so now it says convert to a common unit. So how could I write thirds and halves in common units? Well, that's your least common denominator. What is the least common denominator of thirds and halves? That would be sixths, right? So I could change this to sixths by multiplying by 2 over 2, and I could change this to 6 by multiplying by 3 over 3. So that gives me 14 sixths plus 3 sixths. Now I have a common unit, and that unit is sixths. Now I can combine those and say, okay, I've got 17 sixths. And you could leave that answer like that just to practice mixed numbers. Let's go ahead and write it as a mixed number. 6 goes into 17 twice, which is 12. And so 17 minus 12 is 5, 6. So it's 2 and 5/6. All right, let's see what you can do for B and C. Go ahead and pause the video and give those a try. All right, well, you probably figured out we can add the feet and the feet. So I got 5 feet and 8 feet, that would give me 13 feet. And then 6 inches and 2 inches would be 8 inches. Now, if I wanted to combine these two things together further, I would have to change the feet to inches or the inches to feet. I would probably change the feet to inches by multiplying by 12. You could change the inches to feet by dividing by 12, and you'd have a decimal. Maybe we should show that as well. So if I multiply this by 12, let's see, I get 156. So that would be 156 inches plus 8 inches, and that would give me 100 and what would it be, 64 inches. Alright, let's say I wanted to change it to feet. So I'm going to leave the 13 feet, but I want to change the inches to feet. So the way I do that is I divide by 12. Alright, so if I do that, I have my 13 feet, and 8 divided by 12, if you punch that into your calculator, you're going to get 2/3 or 0.6 bar. That means 6666666 feet. So 13 feet plus 0.6 repeating feet is 13.6 repeating feet. Now we have a common unit. Alright, C, we've got 5 hours and 7 hours. That's 12 hours. 2 minutes and 54 minutes would be 56 minutes. Now if we want to change everything to minutes, we're going to take our 12 hours times 60 minutes plus the 56 minutes, and that's going to give us 720 plus 56, or 776 minutes. If I wanted to change to hours, I would take my 12 hours plus, now how do I change 56 minutes to hours? I divide by 60. 56 minutes, should be hours, 56 minutes is 56 sixtieths of an hour. So I could keep this as a fraction if I wanted to. Up here I divided it and got a decimal, but I could keep this as a fraction and reduce it. Let's see, that would reduce, I think 4 goes into both of those numbers. So it would be 14 fifteenths hours. Or I could literally type into my calculator 14 divided by 15, and 14, I'm punching it in, 14 divided by 15 is 0.93 bar. So 0.93333333 bar hours. So when are we able to add quantities? When are we not? We're able to add quantities. We're able to add quantities when they have a common unit. They have to have the same unit of measure, whether that's feet, inches, thirds, whatever, when they have a common unit. We can't add them if the units are different. We would just leave it. I mean, when we say we can't add them, what we mean is we can't combine them into one thing. Like 12 hours, 56 minutes. All right, I'm not going to add the 12 and the 56 and say that's 68 somethings. Or the cats and the dogs, right? It's 6 cats. I'd have to change and do a whole new unit. In this case, you could say animals, but it's a little bit of a different kind of case. Here we can say 6. We could change them to a common unit of 6, and then we could combine them. But they have to have the same unit if we're going to combine them together. Alright, so here we're still on page 179. We could see from the exploration that we're able to add only like quantities. If quantities are unlike, we have 2 options. So when we say like, we mean in the case that we were looking at, they have the same unit. We could find something common about them, like the minutes and hours. They have something in common. We could change hours to minutes and vice versa. Or we could just leave the quantities listed separately. For example, if we have 5 quarters plus 6 dimes, we do not have 11 quarter dimes. We have 11 coins, which is a trait they share in common. Or we could just leave it as 5 quarters and 6 dimes. Keep this context in mind when we move to more abstract cases with variables. Alright, so we're going to take a little break. We're going to explore some algebraic notation, specifically multiplication. So there's a lot of ways to write multiply. This is how you learned it in grade school, 3 times 4. You're probably used to seeing this one. Now, if you have two sets of parentheses and there's nothing in between those parentheses, that means multiplication. Even if you have a number next to a parenthesis and there's nothing in there, there's nothing between the 3 and the parenthesis, that means 3 times 4. We could put just a 3 in parentheses, or we could use a dot. Okay? And that's with two numbers. Now, if we have a number and a variable, like 3 and n, we could do the same thing, right? So this is kind of the same as that, using two sets of parentheses, or using one set of parentheses, or using a dot. But when we have a letter with a variable multiplied together, this is the most common way that we're going to write that. So if we say 3n, that means 3 times whatever number n is. And that's how we're going to write that. If I want 3 plus n, I have to put a plus there. If I want 3 minus n, I have to put a minus there. If I want 3 divided by n, I have to put a divide there. If I want 3 times n, I just put them together. And that means 3 times n. So notice that 3 with a xn is not listed because it's not listed here in these options because x can be mistaken for a variable. So we don't really want to use it for multiplication anymore. Alright, I think we're going to skip number 5 actually, and let's just go to this business, which is in the middle of page 180. So there's important terms here, and the first term is coefficient. Okay. So we've done some work before talking about constants and variables, and you had some questions on this before to identify the constant and the variable. So if you have the term 5m, 5 is the constant, m is the variable. And we've also talked about what an expression is. That's something without an equal sign, something like this. So the coefficient is really the same as the constant. So if we have the term 2xy, the coefficient is the number that's given, 2. The coefficient tells you how many of the items are being counted. And the x and y would be the variables. When no coefficient is listed, it's assumed to be 1. So let's say you have like just 3x plus y. Alright, so we have terms here. We should probably talk about terms. The terms are separated by the plus and minus. So if I like draw a line here, every time I see a plus, I'm going to draw a line, plus or a minus. I have two terms. So the coefficient on the first term is 3, and the variable is x. The coefficient on the second term, there's no number here, so we know that that number is 1, because 1 times y is y. And the variable is y. So a term can have a coefficient and a variable. Now, if a term has the same variables, then they're called like terms. And we've got some examples coming up here. So let's just look at some examples. I think that's the easiest way to go over these guys. All right. Use the coefficients to help you count the objects in each question. Although the following problems look different from number 1, only the notation differs. The idea is the same. Okay, so let's look. I'm going to write this a little bit bigger. We've got 7x plus 2y minus 3x minus 4y. First question, how many terms? So remember, you're going to separate those where you right before your plus or your minus. So 7x is a term. Positive 2y is a term, negative 3x is a term, and negative 4y is a term. So there's 4 terms. Write the expression in words. I don't really want to take the time to do this, but you could go 7 times x plus 2 times y minus 3 times x minus 4 times y. That's what it is. We don't have to do that. Alright, so if we look at these terms, remember to be like terms, they have to have the same variables. So let's highlight the coefficients and the variables like we did over here. So we did the coefficients in yellow and the variables in pink. So let's do yellow. So coefficients are 7, positive 2, you got to carry the sign, negative 3, negative 4. So if there's a subtract there, your coefficient is negative 4. And then my variables are x, y, x, y. Alright, so in order to be a like term, they have to have the same variables. Let's actually do this in a little darker pink. So this y and this y, obviously those are the same variable. That means this term and this term are like terms. There are two types of terms in this expression, those with x's and y's. Underline the terms with x's and draw a squiggle under the terms with y's. Okay, I should have read my directions. Alright, let's do some squigglies. So we've got squiggly, these guys, and then underline, underline. So now we've identified the like terms, now we can combine them. So again, the hardest part of this is the sign. This negative goes with this 3. So 7x, take away 3x, leaves you 4x. So this would be like 7 dogs, take away 3 dogs. And here we've got 2y's minus 4y's. 2 minus 4 is negative 2. Negative 2y's. So again, you're combining the coefficients and you're leaving the variable the same. And this kind of sums that up for you. So you want to identify the like terms, and then you want to add the coefficients and keep the variables the same. Now this example is a little bit crazy. It's got some crazy terms in it. Let's look at this one, not just plain old x and y. Let's identify the terms. Step number 1, identify the terms. So we're gonna, there's our first term, there's a plus, so I make a line, da 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 da, minus, make a line, make a line. I have 4 terms. Let's highlight the coefficients in yellow. Coefficient, 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 and let's highlight the variables in pink. Variable is xy, y squared, xy, no variable. So what's in that pink glob has to be exactly the same in order to combine them. So this term has an xy and this term has an xy. Therefore they are like terms. That one's got a y squared. I don't have any other y squared, so there's no term like that. This doesn't have any variables. I don't have another term without variables, so that one's all by itself as well. So the only 2 that I can combine are these 2. Okay, how do we combine them? Add the coefficients. That's the part in yellow. Add the coefficients. So negative 5 minus 10. Think about it. What is pictured on a number line? Negative 5. Take away 10. No calculator. Negative 15, right? If you're at negative 5 and you take away 10, you're getting deeper in the hole. What do I do with the variables? I keep the variables the same. Keep the variable factors the same. So that was a xy, so that stays xy. And those 2 terms are combined. Now what do I do with these other 2 terms, the 7y squared and the 2? Just bring them down. Positive 7y squared, positive 2. There's nothing to combine them with. So I just leave them by themselves. And this expression is simplified. I know it doesn't look very simple, but that expression is simplified. Alright, let's pause the video. And I want you to try number 7, all on your own, and then we'll see how you do. Alright, take a look. How'd you do? Now, a couple things here. I highlighted the variables that were the same in tried to be the same color pink. So these two terms are the same, so I can combine those together here. The 23 comes down. This x squared and this x squared are the same, and this y are the same. These two are like terms because the square root of x is the same. And then I have an xy terms I could put together and two x terms I could put together. Now there are other ways to write this that are still correct. We haven't really talked about what order you write these in. What if on this one you put the y's first? What if you did the 4y plus the 8y and you did that first and you wrote 12y and then you did the x squareds and you're like, okay, so then I have positive 24x squared, and then you brought the minus 12 down. That's fine. That's right too. Okay? You just have to make sure that the sign goes with the term. So for example, on A, let's say you just brought the 23 down first, and then you did, remember this is 1A. This might be another thing that got you. Remember this is 1A if there's no number written there. So I got the negative 8 by doing 1 take away 9. 1 subtract 9 is negative 8. So you could write negative 8A. You could write it that way. You could also write it, remember subtraction is the same as adding a negative, so you could write plus negative 8A. And so this is where it gets a little tricky. There's multiple ways to write it, and it's all correct. Okay? And so you might look it up in the back of the book. Let's say you look up an answer in the back of the book, and this is the answer in the back. And you had one of these two, and you're like, oh, I don't know what I'm doing. That's not true. Both of these answers are perfectly acceptable. So you have to be able to look at it and say, is my answer equivalent to that answer? Now let's say your answer was 8a minus 23. Okay, that would be wrong. If this is the correct answer, these are not equivalent because this 23 is negative and this 23 is positive. And this 8 is negative and this 8 is positive, so those are not the same. Okay? Alright, hopefully that helped a little bit. Let's see, moving on. Okay, important terminology here. So, a polynomial is any expression with one or more terms that it's a product of variables and constants. So, all these that we did, these are examples of polynomials. So, polynomial is your overarching term. A monomial is a polynomial with one term. A binomial is a polynomial with two terms. A trinomial is a polynomial with three terms. Okay, before we talk about degree, this is actually on the next page, page 182. If they ever change this book, these page numbers are going to be all messed up. If the expression is a polynomial, identify it as a monomial, binomial, or trinomial, or none of these, and identify its degree. Okay, actually, one more thing we have to talk about. Let's go back to this definition. To be a polynomial, it has an important distinction right here. Any exponents on variables must be whole numbers. There's lots of vocabulary here, right? Exponents, remember what those are? Those little numbers up above that tell you how many times you're multiplying. Variables, I think you know what those are, have to be whole numbers, all right? These are the whole numbers. So you can't have any fractions in your exponents if it's going to be a polynomial. All right, so let's look over here. First of all, let's identify the number of terms. Okay, we've got 5, then we run into a minus. Then we have negative 3y squared, so that's 2 terms. Let's check out the exponents. Here's my exponent, which is a 2. That's a whole number, so we're good there. So since I have 2 terms, it's called a binomial. So a binomial is a type of polynomial. So this would be a binomial. You could kind of think of this in a hierarchy where a polynomial is the overarching term, and then binomial, or let's start with monomial. Monomial is a type of polynomial with one term. Binomial is another type of polynomial with 2 terms. Trinomial is a type of polynomial. And then if it has 4 terms or 5 terms or 6 terms, we usually don't go quadnomial, quintinomial. We usually don't say that. We usually just call it a polynomial after that. Poly meaning many. So let's say I had 3a plus 5b minus 6c plus 10d minus 8e. That's 5 terms. So it's a polynomial, but it's not a monomial, binomial, or trinomial because it's got 5 terms. I just call it a polynomial. All right. So why don't you pause it right here on number 8. I want you to see if you can figure out if these are polynomials, first of all, and then if they're a polynomial, are they a monomial, binomial, trinomial, or maybe just a polynomial? All right, take a look, see how you did. If you need to pause the video to take a look, that's fine. So I'll just highlight a couple things here. C can be a little tricky. This just looks like a number. Well, it does count as one term. It counts as one term. It's a constant term. It doesn't have any variables. It's still a monomial. It does count as one term. D, we've got 4 terms. X cubed is a term. Positive x squared is a term. Negative x is a term. Negative 1 is a term. So it's 4 terms. So we just call it a polynomial. E is a little tricky. It has an exponent of 1.5. Remember, any exponents must be whole numbers. 1.5 is not a whole number, so this is not a polynomial. And there's some special characteristics of those, but okay, this is just a monomial. There's no pluses or minuses here. It's one term. And here we have a binomial. All right, let's go back to the previous page and look at our last vocabulary word, which is degree. The degree of a polynomial in one variable, meaning if there's just one variable per term, is the highest exponent that appears on the variable in the polynomial. Okay, we're looking for the highest exponent. So for example, 4x squared plus 3x minus 5 is a polynomial. It has 3 terms. 4x squared, positive 3x minus 5, 3 terms. It's a trinomial. It's only in one variable, which is x. And the highest exponent on x is a 2. So therefore the degree is 2. Is the highest exponent that you see. Alright, why don't you come back, look at these, and figure out what is the degree. Pause the video and find the degree. Alright, take a look. How'd you do? Let's see. A, there's my highest. 2. 2. This is, there's nothing here. You could think of it as x to the 0. This one's a little tricky. Any constant term has a degree 0. Remember, anything to the 0 power is 1. So if it's a constant term, the degree is 0. 3. This one I'm not going to talk about the degree because it's not a polynomial. It's not 1.5. Okay? It's not a polynomial. If it's a polynomial, then it has a degree. 2 and 4. All right. Very important vocabulary words there, so make sure you know those. Number 9. In the previous lesson, we learned about exponent rules for multiplying and dividing. This lesson explored the idea of addition and subtraction of terms, some of which had exponents. So we're going to put these two ideas together. Number 9. Find the area of a trapezoid whose height is 3 feet long. Long base is 6 feet, and short base is 4 feet. Include units in your work. What is a trapezoid? A trapezoid is a quadrilateral, meaning it has 4 sides, and it has to have 2 sets of parallel sides. These little arrows indicate that these 2 lines are parallel. This is not to scale, okay? I'm just drawing a trapezoid. It says the height is 3 feet. So the height of a trapezoid is going to be the distance between the parallel lines at a 90-degree angle. So that's 3 feet. And I'm going to use that little dash for feet. The base are the parallel sides. So the long base is 6 feet, and the short base is 4 feet. That's 4 feet. Now, we're supposed to find the area of this. Now, I don't expect you to know this formula, all right, but I'm just going to tell you what it is. The area of a trapezoid is 1/2 the height times the quantity, base 1 plus base 2, the two bases added together. So we're going to put the values in for the variables, and we're going to include the units. So we know the height is 3 feet. So we're going to multiply that by 3 feet. Okay, and base 1 and base 2, it really doesn't matter where you put these in, but their two bases are 4 feet and 6 feet. So we'll do 6 feet plus 4 feet. And we haven't talked about order of operations yet. That's actually coming up. But we have to do what's in the parentheses first. I think most of you have probably seen that before. So, can I add 6 feet plus 4 feet? Well, yes, I can, because they have the same unit. So that's 10 feet. Now, I have three things multiplied together. I can do that in any order I want. Multiplication, you could switch the order. I think I'll go ahead and do the 3 feet times the 10 feet just because that seems easier. So 3 feet times 10 feet would be 30, and feet times feet is feet squared, or square feet. So 1/2 times 30 is 15, and then I still have square feet. And that's how you find area in square feet. Number 10, find the amount of edging needed for a rectangular desk that is 76 centimeters by 46. Okay, so we've got a rectangular desk, and we have 76 centimeters by 46 centimeters. We always want to draw a picture, and we want to find how much edging is needed to go around this. So I think you guys can do that one. Pause the video and do it. Now remember, we're not just trying to get the answer. We're trying to write this all out with the units. That's the important part here. Write out the units. All right, take a look. So one way you could do it is just add up all the sides separately, and they're all the same unit. So we could just add them all together. They're like terms. Some of you might know the formula 2 lengths plus 2 widths. 2 times the length plus 2 times the width. You could have done it this way also. So you could do 2 times 76 centimeters plus 2 times 46 centimeters. And then you would just do 2 times 76 is 152 centimeters. Plus 2 times 46 is 92 centimeters. And then if I add those together, because they're like terms, I would get 244 centimeters. All right, we're almost done. Last one. We're doing good. Find the surface area of an aluminum can that is 6 inches tall and has a diameter of 2.5 inches. So again, I would give you the formula for this. So here's the formula. Surface area of a can. So this is like, we did some cylinder stuff. We did volume, remember when we were doing medicine? And finding the volume of overfill. So we're doing the same shape, but we're not doing volume now. We're doing surface area, which is the area all around the outside plus the top and the bottom. So the top is a circle, and that has area pi r squared. And I also have a circle on the bottom, so there's 2. So that's the top and the bottom. And then around the outside, the formula is the circumference, which is 2 pi r times the height of the can, which is h. Okay, so this is the height here, and this is the radius here, and you need those two numbers to find the surface area. So we need to find the surface area of an aluminum can that's 6 inches tall. 6 inches tall, so where's that going to go? That's the height. Good, so that's 6 inches. And it has a diameter of 2.5. Diameter 2.5, not radius. So all the way across is 2.5. 2.5. So what would the radius be? It would be half of that, right? Good job. So half of that is 1.25 centimeters. So now all you need to do is plug in 1.25 for R, and, oh, did I write inches and then I wrote centimeters? Why am I doing that? That's what you're asking yourself, isn't it? You're saying, why is he writing inches? Now, why is he writing centimeters? Okay, everything's in inches. Inches, inches, inches. Okay. So now we're going to plug these into our formula. Leave the 2, leave the pi, radius, we're going to put the unit in there, 1.25 inches squared, 2 pi, radius 1.25 inches, height 6 inches. Put those units in there. That's why we're doing this. This is what this is about, this combining like terms. Okay. So again, we haven't talked about order of operations yet, but what we want to do is we want to do this part first, and then we're going to do this part, and then we'll add those two together. Okay? So 1.25 squared, so we need to punch that into our calculator. 1.25 times 1.25 is a big number. Okay, so we're going to bring down the 2. Here, we're going to bring down the pi. So for 1.25 squared, I got 1.5625. And then inches squared, you would just write as inches squared, just like that. Okay. I'm going to finish this part up, and then we'll come back and do this second part. So now I have 2 times pi times this number here. So I'm going to go ahead and I'm going to multiply the 2 times this number, 1.5625, and I get 3.125. I'm just going to leave the pi here. I'm going to show you why. Inches squared. Okay, now let's go do this part. So I'm going to multiply the 2 times the 1.25 times the 6. So if I put that into my calculator, I get 15. Okay, and then I have the pi. I'm just going to bring that down. And then for my unit, I have inches times inches, which is square inches. So I have 15 pi square inches. So now, if you look at this, you'll see all this stuff is the same. Pi square inches, pi square inches. So you could kind of think of that like the variable part. And we have like terms. So we can just add 3.125 plus 15, and we get 18.125. And then just leave this pink part the same. Pi square inches. Now if we want to, we could go ahead and plug in 18.125 times pi and get an estimate. I know that one was a little tricky, but I just wanted you to see it. So on the last page in the wrap-up here, I really want to highlight this right here. What is the difference between 5x squared times 5x to the 4th and 5x squared plus 5x to the 4th? So last section we looked at multiplying, and when you're multiplying, you're going to multiply the 5 times the 5, and then you add the exponents. X squared times x to the 4th is x to the 6th. If I'm adding these two terms, I have to look and see if they're like terms. This is an x squared, and this is an x to the 4th, so these are not like terms. I cannot combine these together. I cannot simplify this any further. It just stays like this. That's all I can do. So when you're multiplying, your terms can have different exponents, and you add those exponents together. But when you're adding, they have to be the same variable with the same exponent to combine like terms. So this is a very, very important lesson. I hope you got everything out of this that you needed to.